Today we will learn about the basic rules on how to group IP addresses into groups or subnets to make IP routing much more efficient. First of all, we will look into why IP addresses must be grouped. Then we formulate the foundational rules of subnetting. After that, we will analyze an example and perform grouping IP addresses. Finally, we will sum up our video with the keynotes. Let's look into why IP addresses must be grouped. As you know, any interface that expects to receive IP packets needs an IP address. Without grouping, a router has to list one entry for every single IP address. Here is the routing table of router 1 without grouping IP addresses in this network. You can imagine the routing table grows rapidly for a bigger network, which makes the routing inefficient or even impossible. In addition to that, there exists processes for a network device to find the hardware address of the other device when it knows the IP address of the other device. It shares the same type of physical network with the other device. By knowing the hardware address of the other device that shares the same network, it can send IP packets to other devices without having the router to forward the packets. In this diagram, the interfaces with the same color can send IP packets to each other without the router forwarding the packets. Let's now go into foundational rules of subnetting. TCP/IP groups IP addresses together so that IP addresses used on the same physical network are part of the same group. IP calls these address groups an IP network or an IP subnet. Grouping IP addresses into subnets make IP routing much more efficient. Here are the two foundational rules of subnetting. Two IP addresses not separated from each other by a router must be in the same group or subnet. Two IP addresses separated from each other by at least one router must be in different groups or subnets. Let's analyze and perform grouping IP addresses in this network diagram. By following the two foundational rules, we can group the IP addresses as follows. These IP addresses of PC1, PC2, PC3 and the interface E10 of router 1 in group 1. The IP addresses of the interface S20 of router 1 and router 2 in group 2. The IP addresses of the interface E10 of router 2 and server A in group 3. After grouping, the routing table of router 1 looks like this. If the number of hosts in each subnet increase, the entries in the routing table stay the same, which makes the routing much more efficient. Let's sum up our video with the keynotes. From the perspective of IP routing, the grouping of IP addresses makes the routing table much smaller. With grouping of IP addresses, a router can list one entry for each IP network or subnet instead of one entry for every single IP address. Here are the two foundational rules of subnetting. Two IP addresses not separated from each other by a router must be in the same group or subnet. Two IP addresses separated from each other by at least one router must be in different groups or subnets. This is the end of this video. Thank you very much for watching.